Okay, so what we've worked on in the past is this little MBOT robot where it has been programmed using, what are they doing, Scratch? A variant of Scratch to get it, right, to move around and everything else. But the problem we have is that it really doesn't do anything except move right now, right? There's no sensors, there's no way to tell where it is, right? It's got these things here. Do we play with these at all before?
No.
No? Okay, so these are ultrasonics. This is a kind of sensor. And let's see if there's anything else. There might be a light sensor or something else on here. But right now, this little robot, it's not really that smart, right? You could just move around or you could use the remote control. So that's where sensors come in, and how sensors talk to the computer that's on this little robot. So since it already has it built in, you've got these ultrasonic sensors. These, one of them is what's called an emitter, and one is the receiver. So what it does is it sends out a sound wave, and the sound wave bounces off of an object and then comes back. Okay, does that make sense?
Yes.
Okay, so if it's far away, it's going to take a little bit longer than if it's closer.
Yes, I heard some of that from your wife.
Right, okay, sure. So do bounces faster. So if we were going to make this little robot smarter, let's come up with a project. I want to be able to put this robot outside and have it collect. What can it figure out outside? What would you like to have it figure out?
I would like for it to figure out to move forward and turn around.
But if you want to like collect information, like if you were going to put this guy on Mars, what sort of thing might you want to collect?
A camera? How dry the ground is?
Okay, how dry it is, a camera.
How thick the air is?
The thickness of the air, right? The barometric pressure, temperature maybe, and if we had it rolling around, we also need to know where it's at, right? So like a car with their GPS, you need to know where it is in the world so it doesn't get lost. All those are examples of sensors. And the cool thing about these robots in the Arduino environment, which you guys have played with a little bit already, right, is that you could use all different sorts of sensors. So let's take a look at a couple of them. I'll pass these around. Look at this giant mess of wires and stuff. Okay. We've got, what do you think all these things might do? You have any idea? You might want to come a little closer so that you could take a look.
All right.
We've got that. And we've got this. I'm going to unplug all my hard work here. That. And this. And this. And this. Okay. So, this is the main board, right? This is an Arduino. It's just a little bit bigger. It's the same sort of chip that is on here, right? Mm-hmm. So same sort of computer in both cases. Now these are different sensors. So we have, any idea what this one might be? It's got this is kind of like a weird antenna sort of thing. This is actually...
Maybe it connects to the sensor thing?
Sure. What it does is it's a GPS module. So with this, it reads the signals from the satellites that are circling the Earth to find your location, just like your cell phone will have GPS. Same sort of idea. So this sensor can be used, what, if we put this on a robot, then now the robot can know where it is in the world
And where it could go.
and where it could go. So you could say, go to this location, and so it knows where it is right now, and it knows a new location, and it could drive to that location. So that's one, right? Another one, this little thing has a battery in it. It's got this little chip. This is actually a clock.
Clock.
It's
Why
just-
would it need a clock?
Well, it would need a clock for why do you need a clock? You need a clock to know when you're getting up to go to school, right? Or go to bed, or things like that.
Oh, I just realized. Right.
Yeah, and most of the time, when you turn off this power on this robot, it forgets everything. It doesn't remember what time it is or things like that. This little battery supplies this clock chip so that even if this is off, it's still keeping the time. Right now, it's keeping the time. So when you turn this robot back on, it could say, "Hey clock, what time is it?" "Oh, it's 6:52. Okay, thank you," and it will update it. Right?
It's like Siri.
Yep. So we've got GPS.
So would that clock need to be used as when to stop and when to move?
You could use it for that, and you could use it. What I'm going to be using this stuff for is an astronomy project where you need to know exactly the right time it is, so you know when your telescope is pointing in a particular direction, which stars are there, and the clock helps me figure that out. This tiny one, it's got that little tiny chip right there. This is a barometer. Do you know what a barometer does?
The temperature or
Close, go ahead.
the air pressure?
The air pressure, correct.
Aw.
So this little device measures the air pressure so that we know if, like, the weather is changing. When the weather changes, the pressure goes up and down. But also, when your elevation changes, the height above the earth goes up or down, the pressure changes. So with this, I could tell, am I climbing up a mountain or not? Or is the weather changing? So another sensor. And these two are similar. And both of these have something in common with this.
My fidget spinner?
Yes, your fidget spinner and these two boards have something in common.
They can both move?
Well, let's take a look at this fidget spinner. And this is a good one because it's weighted down pretty hard.
Do I want to take off the caps for it? Okay.
No, we're going to spin it. Now with this one, when you move it, you feel that it doesn't want to, it gives you resistance. It gives it resistance. You feel how that, when you spin it and you twist it, you've done it a lot, I'm sure.
Yeah, I have.
But you could feel how it wants to stay in one direction. Because this is acting like a gyroscope. So as this spins, it always wants to point in a direction where you started spinning it. The spacecraft, the Apollo spacecraft, and the other spacecraft that went to the moon used things like this, mechanical devices like this, that on Earth, they start spinning, and they keep spinning, and it always wants to point back towards Earth. The technology has changed over time so that this sort of capability is in these sorts of chips in a super, super teeny tiny size. There are actually these are accelerometers and magnetometers and compasses, all in one. So let's do the simplest first, compass. What's a compass tell you?
It tells you where you're at and where you're going.
North, east, south, or west.
Tells you the direction north. It's
North,
always
east,
going to
south,
point
equals.
towards magnetic north, right? And magnetic north isn't the actual top, the North Pole. It's actually shifted slightly off the axis, and its location over thousands and thousands of years changes. But for the most part, right now, we know that if we have a compass, it'll point north, right? Okay, accelerometer. What does an accelerometer do?
It goes faster or slows down.
What do you think?
Haven't learned it yet.
You haven't learned it yet? An accelerometer is used to tell the direction that this board is being moved. So is it going this way, this way, this way, this way, right? Is it getting tilted? Now, I'm sure that you've probably played games on a smartphone where you tilt it.
Yeah.
Or you've played games on other game machines where you tilt it. That is because there is an accelerometer inside of it that measures the tilting. So what will that do? So let's talk about how would we use it. Okay, let's go back to our robot. We got our robot, and the poor robot is pretty dumb. He just goes where we tell it to, but nothing else, right?
Yeah.
We learned that we could put a GPS module on here, and this is a GPS just like a GPS in your car or on your cell phone, so it'll tell on a map where you are. So that makes it smarter. We have a real-time clock, so it always knows what time it is, even if it's turned off, because the battery gives it a little bit of power. We have a barometer, which is measuring air pressure, so we can measure if the weather is changing or if we're going up or down in altitude.
Okay.
We have a compass, so we know which way our front of our thing is. The GPS will tell us, if we're standing still, GPS will only tell us our location, but it won't tell us, am I facing north or am I facing south? You wouldn't know. The compass will tell you that. So the compass tells you, okay, I'm facing north right now. The accelerometer is telling you how fast I'm moving, right? There's another thing though that the accelerometer can do, and it measures the tilt, right? So like your cell phone games, when you tilt the phone, it does things, it does motions.
Yeah.
Why would a tilt sensor be important for a robot?
To see if it's upside down.
Sure. You're on Mars. On Mars, the time for a person on Earth to communicate to Mars due to the speed of light is in minutes or more. So by the time you tell Mr. Robot to stop, it's probably too late. It's already gone over the edge. So you can have that accelerometer, magnetometer tell you, uh-oh, I'm going up a steep hill. And you can have your code say, you know what, if you ever notice that it tilts more than this way, stop. Right? Oh, I'm in trouble. You know, like, oh, it's going like this, and all of a sudden the sensor picks up that, oh, it's gone like that. Well, the sensor will tell you that, and you can say, whoa, 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 back up. We don't want to fall down that ravine. So these are magnetometer, accelerometer, and compasses built in together. And these are really pretty amazing these are actually tiny little machines in there. There is a tiny, tiny little ball on tiny, tiny springs that when you move it, it moves around. And because it keeps track, just like this fidget spinner gyroscope, when it turns on, it kind of locks into the position, and as you move it, it forced to go back. It's measuring it. In this case, the gyroscope is preventing me from moving it, right? In this case, it's measuring it. So if you have a gyroscope, which is like, line it up, keep it running forever, it'll keep pointing in the same direction for as long as it's running. So we went from something like this to something like this. The other interesting thing about these sorts of technologies, like this gyroscope, is huge versions of this fidget spinner are inside giant cruise ships. Why would there be a giant fidget spinner inside of a cruise ship?
For maybe
Any ideas?
those little safety boats, like the emergency boats.
Well, this would just be normal. So why would
Little
so
balloon.
think about
To
how
help it
this.
function?
Hmm.
To help it function?
Oh,
Well, it helps it function, but like, hold it like
to
this.
propel it.
No, hold the fidget spinner like that. You can put down your drink. Just put it right there. That's right. So just spin it and hold it, and as you tilt it, you could feel how it's like tilt your hand a little bit both ways. See how it kind of wants to go back to level. So when we started at level, it wants to go back to level. Why would this be good in a boat, a big ship?
Maybe because in the water, when it spins,
Have you ever been in like a rowboat or a canoe or
Oh,
a
yeah.
small boat? You know how it's kind of tippy? Well, if you're on a big cruise ship and you've got 1,000 people on the cruise ship, they want to have it nice and smooth. They don't want the waves to be making them seasick. So what they have is these giant devices in the bottom of the boat that are spinning like this that help keep the boat level and not shifting along as much. So this little toy is actually used in all sorts of different devices.
these two things are mine. I have more.
You can stop it for now, Roy.